I got off the wires when I close my eyes.
Hello, can you hear me? Hi, Kenenisa.
Hi. Hello. You can hear me, right?
Yes, I can hear you.
Yeah, okay.
So we'll start in a bit. But before we start the interview, maybe you can do some introductions. So I'll start with myself, and then you can do a quick introduction about yourself as well. So my name is Nazran. I'm a member of HSV Group 31, and I've been head of education for HSV Group 43 for about a year now. And I'm also a student at AIT. Introduce yourself as well.
Okay. So I'm Kenenisa. I'm HSV Group 47 from Remote Education, and I'm studying at Hilco in second year.
Before we start the interview, can you please turn on your camera? Also turn on also, and share your screen. So I'll send you a link to the question to the share pad as soon as it's 4:30 or close.
Okay. And sorry if you can hear some background noise.
The noise. All right, we're almost there. You see a link?
Okay. Okay. Can you see what I'm saying? It's connected, I guess. Okay.
Yes.
Should we get started?
Yes, you can start reading the question. Ask questions.
Let me read the question and we can discuss some approaches.
Sure.
Okay. You're given a zero-indexed integer array nums. You can apply the following operations any number of times. Pick any element from nums and put it at the end of nums. The prefix sum array of nums is an array prefix of the same length as nums such that prefix I is the sum of all the integers nums j, where j is the inclusive range from 0 to I. Okay. Return the minimum number of operations such that the prefix sum array does not contain negative numbers. This case are generated such that there's always possible to make the prefix sum array non-negative. Okay. Okay, let me read that again. You are given a zero-indexed integer array nums. You can apply the following operations any number of times. Okay, I have unlimited operations. Okay. Pick any element from nums and put it at the end of nums. Okay. The prefix sum array of nums is an array prefix of the same length as nums, such that prefix I is the sum of all the integers from 0 up to I. Okay. Return the minimum number of operations such that the prefix sum array does not contain negative numbers. Okay. Okay. It is guaranteed that there is always an answer. Okay. Okay. We do not need to do any operations because the prefix sum is doesn't have any negative numbers. Okay. We can. Okay. The minimum number of operations such that the prefix sum array does not contain negative integers. Okay. I think I understand the problem statement. So the problem is asking that if we have some kind of list and we do the prefix sum on it, the prefix sum array should not contain any negative numbers. The way we will achieve that is by selecting some number from inside the nums, and then we can put that number at the end of the list, and that creates a prefix sum array with no negative values. That's what it's saying. Okay, so when we look at the examples, this does not require any number of operations. We can do the prefix sum array here, and it does not contain any negative numbers. Okay. For the second example, we can do the prefix sum, the entire prefix sum. Okay. Then we would have some negative numbers here. The prefix sum array. Okay. Okay. We can do one operation on index 1. We can move that outside. Okay. And that will create. Okay. This is an interesting problem. Okay. Okay. So first, what I'm thinking is just the smallest negative numbers are the ones that are affected are the most. So swapping those out would be a better strategy to solve the problem. For example, here -5 is the biggest, like the smallest negative number we have. So moving that to the end of the list will get us a little bit closer to the answer. But I don't know if that is a clever solution, because okay, the time complexity for that could be very big.
Sorry.
And, yeah.
So the approach you just mentioned is just going through all the negative numbers and putting them at the end of the list, or are you just going to put the smallest negative number at the end of the list?
I'm just choosing the smallest negative number, so that would be -5 here, and then doing the operation on that will be a better strategy to swap out every item. So I need to go through some custom examples to understand the problem a little bit more. So I'm trying to think of an example that, for example, for this example, where we do not switch -5 out to the end of the list, but we would have to be switching -2 to the end of the list, that kind of stuff. I'm trying to think of. So if there is that kind of scenario, then choosing the number to be switched out would be tricky. And also, after we switch out this number, we might have to do we might have to recalculate the prefix sum array, and that could also be costly in terms of time complexity. So I'm also trying to think of that. Okay, so what example do we need for? Okay. Okay, because it's a prefix sum array, the latter numbers, the left numbers, will always affect the right numbers. Right? So, so for example, if the least negative number is on this side and not this side, on the right side, what would be a good solution for this? Okay, so this will generate a negative number, right? So if we do the prefix sum array here, we would have how do we start? Do we start from 0? It should be the same length, right? So we're just carrying the number over. Okay, so this would be 3, then this would be 1, then this would be -4, and this would be 2. Now we still have a negative number. Okay, so can you give me the constraint for the problem?
Okay. So which exact constraints do you need?
The number of nums. How large is
So
it?
the size of the num array is so the minimum size will be 1, and the maximum size you can get is 10 raised to 5.
Okay. So less than or equal to 10 to the power of 5. Okay. So this is a very large number to be doing n squared operations. So we need to come up with a linear solution. Okay. Okay. But do we need to calculate some range sum where we have to update the individual items? Okay. Okay. Is there any hint you can give me here, or am I going in the right direction?
So so you sort of just glossed over the brute force solution. You said it's not fit for an n squared solution, which is true, but you didn't really explain the n squared solution. So maybe if you have nowhere to start, you can start with a brute force solution.
Okay. So the n squared solution would be okay. Let's just think of a brute force solution here. So the brute force solution would be to iterate to just first build the prefix sum array, right? So we can find if there is a negative number while we're building the prefix sum array. That's so we don't have to worry about looking for a negative number in the prefix sum array. So after we do that, we build the prefix sum array. If there are any negative numbers, we will choose the biggest negative number and just swap that to the end. This will not minimize the amount of like operations we have to do, but it's a solution. So let me just write some kind of pseudocode here. So we will just okay, let's just say we have a function that tells us if our prefix sum array has negative numbers or not. So let's just say there is a check function, and then when there is a negative number, we just we will do this operation again. And let's just take a min number, and let's set that to like negative infinity, right? Or infinity. I mean infinity, yeah. So we'll just loop over the array, and then if our number is less than the minimum number we have, we'll just set the min to num. We can also track the index for the minimum number we've seen so far. So we can just say index is something. So we'll just say I. And then now we have the minimum number and its index. Now we can just remove that. So remove index, then append to left, not to the right. Okay. And then we can have some kind of counter here that counts how many operations we did. So for one swap, we can do we can count one more, and then we can just return that output. But I can't prove if this is like if this is the optimal solution. Maybe we need to go to some DP route where we say if we remove this item, what would be the prefix sum array? Okay.
So just to make sure we're on the same page, this is in your brute force solution. You're going to look for the minimum number. And as long as the prefix sum array it has a negative number, you're going to find the minimum number, put it at the end of the array, and then do your check again. on the new prefix sum. And then the same case is true, you're going to find the next minimum array, put it at the end of the array, and do the same thing again. Is that correct?
Yeah. Yeah, something like that would be a for solution, but I don't know if that works. That's what I'm saying.
I mean, if we can assume the check function is implemented correctly and it redoes the prefix sum every time, I think it looks good to me. Yeah, you said DP before I stopped you, so do you have another approach?
I don't know. So because it's a minimization problem, maybe it's a DP approach. I'm not seeing it though. Because we have to do some operations, and I don't know. So for DP, we would have So for DP, we will have some kind of function, so like f of n, and then that f of n should be the result of its predecessors, yeah. So it should be calculated from some numbers behind it or from its subproblems. And also that function should also have some kind of base case where we say f of 0 is 1. So we know where to stop. That is usually the DP approach. Now, I don't know if that is applicable here. I'm also trying to think of a way to solve it using a binary index tree. But I don't know how that is going to help me to find the negative numbers. That helps me like update the array in login time, but I don't know how it's going to help me to do the operations where I have to switch. Okay.
I see. So what maybe is
So one other observation. I can hear you.
Yes, continue. Yeah, continue.
Okay. So one other observation: if we have to switch this this number out to the right, and there is always going to be some kind of solution. So this is such that it is possible to make it with no negative value. If it is guaranteed that there is an answer, we can just turn this into a 0. We can just update this to be a 0, and then calculate our prefix sum based on that. Okay. So,
I guess that makes sense. That simulates.
Yeah. So if we just have to switch this to here, so this could also be a 0. And we can stop caring about -5 because there will always be a solution after -5. I think that's a good approach. Now, what I need to do is okay. So what I need to do is to calculate. Okay. So okay. Some number will generate a negative number, right? So for some function that we have between some range left and right, that means we don't care about the left. So the left is from 0 up to r. We will get some kind of negative number. That is the thing, right?
Sorry, can you elaborate on this point?
Yeah. So let's just take the example where there will be a negative number. I deleted that part. Okay, so I think this is the solution. Okay, so there will be some range. There will be some range from 0, so from index 0 up to some r that is negative. Its sum is negative. That's what creates the negative numbers on the prefix sum, right? So
okay,
if
assuming there's prefix sum.
So let's just say that for the prefix sum of this array, we can go 3 and then -2, and then this will be negative only 4, right? No. It will be 2 plus -2. So that will be -2, something like that. So that means that if we add the numbers from 0 up to r, that means that creates some kind of negative number like this. So if we add the numbers from range 0 up to 1, that means this range is -2. So we can use this to our advantage because we can find the range sum in the log n time. We can just iterate through the array, right? So we can just iterate through the array, keeping track of the negative numbers we have, right? So as soon as we get a negative number, we will just update those negative numbers we have at the back. So we will already have indexes at the back. We will just update them by 0. Okay, so that means that we've just shifted them out of the array. So when we're able to make this range a positive number, we will continue to the next range. And we can also calculate that using log n time. So the entire time complexity of this solution would be n log n. So of n log n. So is that clear?
Yeah, almost. I get what the algorithm is doing. I don't understand how the time complexity got to n log n.
Okay. So I'm saying n because we need to iterate through the array to calculate the range sums for each range. So I will calculate the range. So I need to go to every r possible from 0 up to n. So that is n. And then for each range I find, I need to calculate its sum. So how that is going to be log n is because I'm going to be using binary index tree. And for that, we are able to find the sum of a range. And also we can query that range using log n time. So for each number I have, for each range I have, I will calculate the sum like that. So that will be log n and log n solution.
Okay.
I think this works. And if I can get to the coding, I don't want the time to go by. Is that okay?
You can start implementation if you'd like.
Okay. So let's just call this binary index tree, and I will have def init and the self and size of the array. So let's just call this n, and self dot size is equal to n, and self dot tree is equal to 0 up to n plus 1. Then I will have my update function of self, and it's going to be updated by some number. So that is I need the index to update, and I need the delta to update. Okay, so I need to make the index 1 based. Then while that is less than or equal to the size of my array, I will self dot tree will be index. Then I will increment that by my delta. Then the index will be incremented by index and negative index. Yes. So we're trying to find the rightmost bit. And then here I will do the query and self index. So the query will be for some range, right? So up to some index. I will also increment this by 1, and then I will have a result of 0. Then while my index is greater than 0, I will do index is equal to, I will do the result plus equal to self dot tree of index. Okay, I hope I don't miss anything. Okay, so index minus equal to index, and negation of index. I don't know if this is negative or negation. Okay, we'll figure that out later. And then I'll just return the results. Because I'm doing 0 up to r, I don't need to calculate left and right. So I'm going to skip that part. And then for our function, I need to iterate through every nums. So let me just take this part of nums. Okay, so let me just take this. Call it nums. I need to get the size of the list. And then for I in range of, come on, in range of n. So, okay. So what if the first number is a negative number? How do we deal with that? Okay, I think because it's one index, it will handle it. Okay. So, so I will calculate. So wow. Okay, so the negative numbers I've seen so far, I have to, yeah. So I need the Q for this. So a DQ of some numbers, and then I will just say if I also need its index. Okay, so if nums of I is less than 0, I will append it to the Q. I also need its index. Do I need its number? I don't. Okay, this shouldn't be a Q, right? It should be like a monotonic Q. I'm trying to find like the smallest item I can have to my left. So if I'm standing at, so let's just call this right. Then I'm standing here. But we will think about this later. But the gist of this is, oh, I need to. Why is commenting not working? Oh, like let's see. Okay. First, I need to calculate the binary index tree. So let me just say tree is equal to b IT, yeah, and n. Then I will do for I in range of n. I will do an index and a delta, right? So I will do tree dot update. It accepts the index and nums of I. So that will construct my binary index tree. Yeah. Okay. So okay. So I will do tree dot query while there is a tree dot query, and we're going up to r is less than 0. So there is some number that makes the range negative. So now what I can do is I can update my tree. I can also update my nums array. So that will be tree dot update that okay, I don't know the index now. I will replace this with some index. So just say some index. Do I have time? Okay, so some index, and what I would be replacing it with would be to add that amount of numbers, right? So let me just multiply it by 1 and say nums of some index. I will find this index in a bit. There is like a shorter way to find it, I guess. So when I do this, this number will be positive instead of a negative number. And when I add it to the positive number, that will make it 0. So when I do the query sum again, this number won't be considered again. So it won't affect the calculation anymore. So I also need to say nums of some index. I shouldn't be using this, but okay. and so sum index is 0. Okay, this will actually work, but I need to figure out a way to be able to get these indexes where there will be some negative numbers. Okay, so now I'm thinking of a way. If we just let's just take the first negative number we find. Let's not just care about anything. And okay, so let's just take the first negative number we find. So for that, I would be using the same approach I was using earlier. So that would be if we have a negative number, we just append the right, and then what I would do is for this sum index, I would be doing q dot pop left. So that would be sum index is going to be q dot pop left, right? So this would give me the numbers I've seen before that are negative. And then I can take those negative numbers and just to swap them and recalculate my rate, yeah. And at the end it would be, yeah. So the operations I'm doing where I have to update the array. So I'm just going to say count is equal to 0. And then because I did some update here, I will say count that is equal to 1. And then at the end, I will just return. I think this would be a good solution. If I didn't mess this up, which I have to try out. So let's just try out this see out, and let's see for let's check for some syntax here. Because undefined, we can just do collections. Okay, what is this saying? Oh, plus I said plus. Okay. What else? Okay, so there is some infinite loop, I guess. But this would be popping left, so it would be empty, so there wouldn't be any.
Yeah, it's fine. We've passed the 30-minute mark, so I guess we can stop here. Well, thank you for joining. We will let you know the decision, I think, later on today.
Okay, thank you.
All right. Thanks.
Bagagin ka dun siya. Krelo.
Hi, Yohans.
Hi, here another. I'm good. How are you?
All right, so I'm just sharing my screen so you're already. Before we start the interview, just two quick introductions. I'll start with myself and then we can continue. My name is Nazrawi. I'm a fifth year software engineering student. I'm also a member of Group 31 in HSC, and I've been a head education for Group 43 for about a year. Continue.
Okay, I'm Yohans. I was part of Group 32. Now I am head for Group 49 in the remote part of HSB. And I just graduated like a few months ago.
All right. I'm going to send you a link to the share card.
Okay. You are given zero indexed integer of array names. You can apply the following operations any number of times. Pick any element from names and put it at the end of names. The prefix sum array of names is an array prefix of the same length as names, such that the prefix is the sum of all integers named j, where j is in the inclusive range from 0 to I. Return the minimum number of opportunists such that the prefix sum array does not contain negative integers. The test cases are generated so it's always possible to make a prefix sum array negative. So it's always not negative. It can be possible. Okay. In this case, there is no need for operation. Great. There is one operation needed. So the operation is again to pick any element of names and put it at the end of names. Okay.
Yeah.
So in this case, he picked this one and put it to the back, as I can see here. Okay. Okay. Got you. And it's saying that it's always possible.
Yeah.
Possible to make it all possible for the prefix. So, I mean, one observation I have is like at the end of the day, it's going to be like at the end of the array, if this is the array, all the elements here will be like the negative ones. If the number is positive, I mean, like we don't have a problem, but if it's negative, we might or may not like postpone, like put it at the back. So these elements will be like negative. And one observation is like at minimum, we can have 0 operations, and at maximum, like, I mean, n operations, or like n minus 1, but it's just around the same. Okay.
I think I managed.
Okay. I mean, like, what would be the brute force way? Let me like think about the brute force way.
Yeah. It's a good place to start.
Yeah, for sure. The brute force, I will like, I just go on like moving on one by one, and whenever my prefix sum is below 0, I will make the the last element to the back. And doing this, I can have the prefix sum. So in this case, like here I have 3, and like when I encounter this element, it became negative. So I will just do this. I have no choice to do this. I have no other choice of not doing this. And like the problem is like to do this, I can just replace it with 0. It's fine. And like I can also just ignore it, you know. It's here 5. I can just ignore it and continue to this part. You don't have to like literally remove it from the array. So I can just continue my journey. Here I encounter -2. So my prefix sum is like 1 here, so it's fine. Then I encounter 6, it became 7, and I encounter this, it's fine. Okay. So I thought this would be a brute force, but it's actually like working, you know, for this example at least.
Yeah.
Okay, what
So
can be...
just to make sure we're on the same page, yeah, you can go back to the SharePoint, sorry, because I'm looking at your example. So you're going through the array and you're doing the prefix sum as you're going. Is that correct?
Yes, I can just have a a variable that will have the prefix sum on it.
Okay. And then when did you do your operation? Like, what was the key for you to do the swap?
When my prefix sum, the current variable becomes negative, you know, below 0, according to the question. It's saying like it's below 0, right?
Yeah.
It says negative. When it says negative,
correct.
then the current element I will just put it to the back, because I mean I don't have any other option. I have to make that element on the back. If I continue, then that's not going to be not feasible.
Yeah. Okay. So I agree with you on the point that as soon as your running prefix sum becomes negative, you're going to have to do something.
Yeah, I mean,
so maybe you can refine your approach.
So go having a prefix sum, and when the prefix sum became negative, move the current element to the back. I'm just like, thinking if there is some case where we may have to do another operation or some edge cases,
Yeah.
Okay, let's say this is the case. -5, -5, 10, 10, So here I will move this one to this one. I have no option. I move this one to this one. I have no option. Like I'm just, I'm here. I will just literally append it, or I can use some Q to like, not Q actually. So I mean like space-wise, it might be a problem. But it's not going to be so bad, It's just going to be as bad as like twice the array.
Yeah.
So fine, it's fine. I reach here, it's fine. This test case has passed. Maybe. Can I get any help? Like maybe if there is any bad situation here. -100. Then like 5. It's not so bad here also.
Yeah, maybe try to make the negative numbers different because having two identical negative numbers is not really getting you anywhere.
Yeah, so maybe this one, or also maybe like having a bigger one first and then a small one. So if these are like big ones, it doesn't affect it. In this case, yeah, move it again. So when I move it to this one, it's gonna become like -200, and negative 100. So in this case, like after I finish this parts and I reach here, it's gonna need second operation to it. But I mean, still I have no other options. I will just do a second case.
Okay. Can you explain why you need to do a second one after you've
Yeah.
done the first round?
I mean, if
Maybe
this
to
was,
simulate it.
yeah, in this case. So this came here, and then this came here, and then after that, these two guys are fine. Now let's make these guys like small. Now they are small.
Okay.
Now in this case, it's below negative. Because it's below negative, it has to move second again. It's not happening. Yes, you're right. It's not happening.
This isn't a valid test case, right?
Yes, it's not by test case. So maybe like we can conclude like there might be maybe no. There might be no second operations on a single on a same element. So to make sure this is correct, it feels like so, yes. Are there any more examples, or these are the only ones?
Yeah, these are the ones.
Maybe about the constraints. Can I have the constraints?
Yeah, sure. Which constraints do you need?
The length of the array and also each element's range.
Okay. So the size of the array can range from 1 up to 10 raised to 5 inclusive. And each num in nums can range from negative 10 to the power of 9 to positive 10 to the power of 9 inclusive.
Gotcha. Okay. This is the length.
Yeah.
And this is the element. Okay, so one thing is just to ignore the element. You don't have to we don't have to actually like remove it from the array, and then just append it to the bug. So if all of the elements had the opportunity to be like put it at the bug, the space would be like twice that we need. So maybe just make sure like such test case 4, -2, -3, like let's assume like we have big elements here. Here also it's fine. Okay, I don't seem to find any like contradiction to my thoughts. Let me just implement it. Will it be fine to implement it?
Yeah, you can start implementing. You have around 13 minutes left. I'm not going to pressure you. You can either continue looking for cases that may make it fail, or you can start implementing and then go back afterwards. It's fine with me.
Okay, maybe like let's do some implementation. So of operations. Okay. This should be while loop, you know. Or we can just check before adding. And else. And just call it result. Okay, this looks simple. Let me just keep on. Like, do you have any questions on the implementation? Anything?
Yeah, maybe you can explain the two branches because that's basically the main part of the code.
Yeah. So before I add the current element, I will just check if after adding it might be less than 0. So if this is the case, I will like append it to the back of the array and continue. Like I will just continue my iteration.
Okay.
If not, I will just add it to the current sum, to the prefix sum.
Okay.
And
so prefix sum is only affected in the second branch.
yes. I will just ignore as if this element doesn't exist in this case.
Okay.
It's making me negative, If it's making me negative, I don't want it to make me negative. So I will put it. I will postpone it and continue.
Okay. So this is simulating removing it. Gotcha. Okay.
Okay. 8 cases. If just -1, this is not a valid answer. Add it 10, it will be, 10 -1. My concerns are like this might go on forever for some case, for some edge case it might go forever, but I don't think that will happen. Also, how can that happen? Let's say if it's this is not valid answer. This is not a valid answer. This is will do it. This one will do it. 3010. That's good. Just 2 elements. Just 2 elements, like one of them have to be bigger. So we don't have any problem. For sure, we have no problem if they are just 2 elements. Let's say if they are equal. If they are equal, let's say it will be 10 -10, and no problem. Okay. 2 elements fine. 1 element is also fine. So 3 elements.
Maybe it could be helpful to remember like something that was said like around the end of the question description. I think it told you that it's always going to be valid, right? So maybe you can start thinking about where the boundaries lie between valid and invalid test cases.
Okay, so if it's going to be valid, if it's valid, the total sum is just a simple constraint is total sum should be greater than 0. This will guarantee that the last element will be positive. Another guarantee is to have all negative numbers here, like this, and all the positive ones minus the negative ones. This should be like this. This number should be, the sum of positive ones. Positive ones should be greater than all these numbers summed, greater than sum of the negative ones. This is also the same. I sum them all and like I start decrementing from the negative ones, So it doesn't matter the order, as long as I have the positive numbers summed up together, I have summed them all together first, and then I start decrementing the negative ones, So as long as all of them summed is greater than this one, it's just fine. So these are the two conditions, which is the same as this one. Yeah, so as long as this is the case, this will happen. So, like one proof I have is what will my application do is, So one thing is like we need to minimize the operations, We need to minimize the operation. Okay. So sometimes it's going to be fair to move them, even if we don't have to wait until we don't have to wait until it's negative. Probably, Maybe.
Okay, I think I see what you mean. Maybe you can elaborate more.
Yeah, maybe it's not optimal. Optimal to to swap, what do you call it, to postpone for an element. Why? I can ask why here. Why would I need to postpone element early on? Let's say it's a big one, So it's element, I encounter a big element here. So I encounter a big element here, but it's not making my current sum. It's not making it negative, but it's a big one, So because it's a big one, it's just better to move it. So this makes everything rubbish here. This doesn't work. This will make sure, but it's not optimal, not optimal amount of operations. We can do less than this. Okay. So for each negative number that we encounter, we have to decide whether to move it or not.
Yes. And how would you decide that?
One way is to do just brute force way backtracking, but we can use dynamic programming. So let me move this code up. Let me move this port up. It's actually useless. Let's just be it here. Okay. What is the operation? Let's talk about the optimal solution now. So for every negative number, we decide whether to postpone it, to push it, to push it or not.
Yeah, I understand.
Okay, so if we push and not push, two cases. One is push, the other is not push. So some sort of knapsack going on here. So the brute force way is just it's going to be like having a recursive function with custom array and index. This way, we can brute force way it. We can decide for each cases, and on the base case, if I is in here, we calculate the minimum. Okay, this is using some some sort of deciding, but can't we be greedy about it? I'm thinking maybe we can we can be greedy about it. You know, maybe there is might be a greedy solution here.
Yeah. So deciding in the future instead of having to look at both possibilities now is what you're saying, right?
That's one way of to do it. Maybe also like if the current number -1, like we have some conditions, and if it's fulfilling those conditions, maybe we can postpone it. Okay.
So what would those conditions look like?
Sorry.
Yeah, just said what would those conditions look like?
Yes. I mean, like this doesn't like get us. We may not have optimization for this one, so let's just think greedily. And
Okay.
we have a negative number. We have a negative number, and let's just think about the conditions. If this element is, greater, like really big, I mean, like just when you like thinking about it roughly, if it's really big, it has to be postponed, even if it's not making us negative. Yeah. So we have an array. We can like go back and postpone. Okay. So what I'm thinking, like just add them to some sort of heap, and then like go back and remove them. Okay. I
That
guess
makes sense.
Yeah, I got the solution, I guess. So you go, as you go, put the negative elements to heap. And when you get to a solution where your current sum is below negative, you look at the heap. That heap contains the biggest element, and you move it to the back of the array. You got the idea?
Yes.
Let me do it real quick, So
Yeah.
let me call it get operations.
Jules, yeah, we've run out of time, unfortunately.
Bad.
Oh wait, no, we have 4 more minutes. My bad. We started at 4:05.
Okay.
You can implement it.
Okay. 4 minutes is fine. So heaps. I have a heap. It's going to be a min heap. So for still, it's going to be. I mean, like if we put it to the back, it's not important. It can stay there. So for val in array, if val negative less than 0, heap push, heap val, current sum, val, and what was it? Current sum is 0, and if current sum is less than 0, here what we do is we get the element from heap. So there should be some element in the heap, obviously. So min element, let me call it just P for now. Heap pop, heap. And this value should be like removed from current sum. It was added to current sum before. It should be removed from current sum. It's removed from current sum. Yeah, doing this way, we have one operation here, a result. So it may not be one element, sorry, here, like it may not be one element. We might need like to pop many elements. So while heap and while current sum is less than 0. Just replacing this one is while we'll do it. And I'm just to safety, let's have this one. While heap and less than, yeah, I think that's it. And then returning result. Okay, so any element that is popped from here is going to be put to the back. All the elements at the back, they are going to be negative. They are not important. They will be just there because the test case is valid. Okay, any questions? Maybe anything that I should clarify?
Yeah, it makes sense to me. Maybe I would suggest going through it one more time and trying to think about any bugs you missed, maybe related to the parity of the stuff you're copying and inserting and stuff.
Yeah, okay, so heap. Let me just comment every line. Creating a heap. My result. My current result. My current sum. Initially 0. Looping on array. If val is less than 0, add it to the heap. Yeah, heap push val, and adding it to the prefix of while heap and current sum less than 0. This means we are at emergency, so we pop the minimum element, of course, like the one who is like making the maximum influence element. So it's like -100 is going to be popped if those is the case. I mean, this one is the enemy. Okay, we have it. So we previously did this. We did this like the same thing here. So now we are going to decrement it, obviously. So this operation is going to be +1. This is one operation.
So, yeah, we're out of time now. I think I'll share my screen and I'll submit it as you watch, okay?
Yeah.
This function, or the whole function.
It's a very tricky question, man. It's just oh, should I stop?
Yeah, I will share my screen. Okay. Yeah, so I guess.
Oh, there is some indentation thing here, like return the set.
Oh, sorry. Yeah. And then this goes one step back as well. So this is more or less looks correct, right? In terms of syntax. So let's submit this. Nice, nice work. All right.
Thank you. Thank you very much.
All right. Thank you, Joe. You'll get the decision later today, I think.
Yeah,
All
goodbye.
right. Joe. Bye.
Right. Okay. So I'm Brooke. I was the interviewer for the first matchup between Mukarram and Burhan. It was a tough decision, I'd say, because after all, we couldn't submit both of like the implementation of both of the candidates. But we have been going through the implementation and the notes that I have tracked with the other heads and also some other guest judges, basically. And and after like a thorough evaluation of their performances, both technical wise and the other interview qualities that we want to see in our interviewees, we have made our decision, and our finalist is going to be Burhan Antenna. Congratulations, Burhan. Burhan is going to be the first finalist in ATOSP Champions League 2023. Thank you.
And I guess I'm going to announce the second finalist. I was judging the match between Kenenisa and Yohans. And in the end, only one of their codes was submitted and passed. So the second finalist is going to be Yohans.